So now let me introduce combinations. And combinations are arrangements of objects in which the order of the objects doesn't matter. So that's really important. The order in which they're chosen just doesn't matter. So let's just come up with a really simple example here. Let's say we have three letters, A, B, C. How many arrangements of two letters could be formed in which the order doesn't matter? So for example, AB would be equal to BA. Well, we could choose AB, we could have AC, and BC. That's all. So if we're choosing two objects from three, so 3 for N, choose K, 3, choose 2. This is what we did here. We would have three choices. And I'm just going to use the formula to prove that that would be the case using the formula. So N in this case is just 3 factorial over 3 minus 2 factorial, because our K here is 2, times K again, which is just 2. And I'm assuming that you're comfortable with factorials already. If not, you can check them out on our website. So 3 factorial is just 3 times 2 times 1 all over. Now 3 minus 2 is 1. 1 factorial is just 1. So I won't even write the factorial there. And 2 factorial is just 2 times 1. So 2 times 1 cancel out with 2 times 1. 3 over 1 is just 3. Great. So we were able to figure out that if we have three objects, we can choose, and we're choosing two, there are three ways to arrange that if the order in which they're chosen doesn't matter. So let's say, what if we have A, B, C, and D now? And again, we want to choose two objects, or just two letters, A, B, A, C, A, D, and so on. That'd be 4 choose 2. So we have 4 factorial over 4 minus 2 factorial, 2 factorial. So that would be 4 times 3 times 2 times 1 all over. 4 minus 2 is 2, and 2 factorial is just 2 times 1. And we have another 2 factorial over here, which is also 2 times 1. Great. So now 2 times 2 down the bottom here, this whole denominator, 2 times 1 times 2 times 1, that's just 4. So we can actually just cancel the 4 on top with the 4 on the bottom. So they all cancel out. And we end up with 3 times 2 times 1, which is just 6. So there are 6 ways to choose two objects from 4 if the order doesn't matter. The order in which they're chosen doesn't matter. So let's see if that's right. So we have A, B, A, C, A, D. We also have B, C, and B, D, and C, D. So 1, 2, 3, 4, 5, 6. There we go. So that's a very simple explanation for combinatorics, or sorry, for combinations. And I just suggest that you try a few questions, and good luck.